Hello world, Adam here, aka Mushroom Tech. Welcome to my Coding Particles series, episode 1. In this episode, we're starting with the basics. I'll show you how to code bouncing balls using what I think is the simplest method to understand. To demonstrate this, I'll be using a library called P5JS to draw the graphics, along with JavaScript. However, it should be possible to follow along using pretty much any programming language that is capable of drawing circles to the screen. Let's get started. So I've gone to the P5JS website. From there you can click on the editor. Always remember to log in at the top right before you get started. That way you can save your work. As long as you click save in the file menu once, it will start auto-saving. When you start a new project in the P5JS editor, it adds a few lines of code to help get you started. There are two functions: setup, which is where you put any code that needs to be run just once when your program first starts, and draw, which is where most of your code will go. Any code in the draw function will run over and over, 60 times a second, so it's great for animation. There's also two commands already added to the project for us. Inside the setup function, there's the create canvas command. This creates the canvas that we draw to. We can see it's got two numbers, both 400. The first one is how wide the canvas will be, and the second one is the height of the canvas. In the draw function, there's one command, background. What this does is it fills the canvas with a solid color every single frame. If we run this, we'll see that we've got a grey box come up. It's grey because this number here is representing grey. If you do 0, it'll be black. And if you do 255, it'll be white. Any number in between will produce a grey colour. We can also type colour names in here. We do that by adding speech marks and then whatever colour you want to add. So if I type in cyan and we run this, we get a cyan canvas. Or if I type black, we get a black canvas. The reason I like P5JS so much is it's so easy to get started. Let's add a circle. So I type the word circle and I add some brackets, and then we need to add 3 parameters. The first one is how far across it is. So our canvas is 400 pixels wide. So if I type 200, that should be halfway across the canvas. I then add a comma. The second number is how far down the canvas it will be. If I type 100, it should be a quarter of the way down the canvas from the top. And the third parameter is the diameter of the circle. I'm going to add 100. I'm also going to add a semicolon at the end of the line. This is actually optional in JavaScript, but because most of the P5 documentation shows it, I'm going to use it too. If we run this, we get to see a white circle, which is 200 pixels across, 100 pixels down, and 100 pixels in diameter. Simple. Now I'm going to create a variable. Variables hold information. We can create the variable with the keyword let, and then we give it a name. There are some rules about how variables can be named. I'm going to call this one position x, and then I'm going to give it a value. So we'll say equals, let's say 0. I'm going to add that semicolon. So what can we do with a variable? Well, these numbers that we're producing our circle with, we could replace them with a variable name. So I'm just going to copy my variable called position x, and we're going to paste it in instead of this 200 here. And if I run this code, we now see that the circle is right on the left hand side at 0 pixels across the canvas. So what's this gained us? Well, not much yet. But the thing with a variable, like its name suggests, is that it can vary. It can be changed over time. And remember that the draw function is running 60 times a second. So if we change the variable inside the draw function, it should change the position of the circle. So how can we do this? I've clicked at the end of the last line inside the draw function, and then I'm pushing enter to get a new line. I'm then going to type position x, which is the name of our variable, equals position x plus 1. So what that means is it's going to equal itself, whatever value it's currently at, with 1 added to it. So if I click play now, we've got animation, moving circle. So the first frame, position x equals 0. The second frame equals 1, and then 2, and then 3, and 4, and so on forever. Once the circle goes off the screen, it will carry on counting. The variable doesn't care that it's been used to set the position of a circle. This is a bit lengthy. There's actually a shortcut for this. Rather than having to say position x equals position x plus 1, we can instead change it to position x plus equals 1. It's a nice shortcut, saves some code. It does exactly the same as position x equals position x plus 1. Nice. So now I'm going to do the same thing with position y. Let's create a new variable, and then I'm going to change it down here too. Change that to y. And for the second parameter for the circle, which is the y, which is how far down the canvas it is, I'm going to say position y. What do you think is going to happen now? It goes diagonally. So they both start off at 0 and they're both increasing, and therefore we go across the canvas and we also go down the canvas. Well, this is animation, but it's not really a particle yet. What is a particle? I guess it's an object that has some kind of rules in the way it behaves. One of those rules would be the speed and direction in which it's travelling. We could set an angle and say that the particle is going at this angle and at this speed, but that can be a bit tricky sometimes to code. It's much easier if you create a variable that holds the velocity, which is the speed it's going, for both the x, the horizontal speed, and also the y, the vertical speed. This is known as a vector. So let's create two new variables that are going to keep track of that. There's actually a shortcut. If you hold Control when you click somewhere, you can have two cursors, so we can change both things at once. So I'm going to change this to velocity x and velocity y. I'm also going to change the position of the x and the y to the middle. You'll see why in a moment. So for now, I'm just going to set the velocity x to be 1. And I'm going to set the velocity y to be 0.5. Okay, so down here where we're manually changing the position, instead of adding 1, we're going to add the velocity. So adding velocity x there, and velocity y here. Watch what happens when you run this. So we're going towards the right and we're going down, but we're going right faster because on line 3 you can see our velocity x is 1, so our horizontal velocity is 1, but our vertical velocity, the velocity y, is only at 0.5, so it goes down slower. It would be nice if the velocity was randomized, so every time we played it, it looked different. I'm going to use a setup function for this. P5.js has got a special command called random, which sets a random number. However, it can only be used inside of the functions. We can't use it up here. That's because P5.js isn't actually ready yet when it runs these lines of code. So I'm going to say velocity x equals random. Add on those all important brackets at the end. So these commands that we're typing, they're actually functions. They're functions that are hidden from us. They exist elsewhere in the P5.js library. And whenever we call these functions, we must add these brackets on afterwards or it won't work. I'm just going to copy this line so we use it for the velocity y as well. And then if we run this, we should see we get a different movement each time. The velocity is changing every single time we run our program. Now we no longer need these numbers up here because we're overwriting them as soon as our program starts. So I'm just going to remove these just to make it clearer what's happening. So here we're now creating a variable, but we're not assigning it any value, which means it's a null value or none in Python language. It's not got any value at all. And it still works exactly the same way, because when the program first starts on line 8 and 9, we give it values. Now you notice it's always going to the right or down still. That's because the random function produces numbers between 0 and 1. But what if we want other numbers? Well, the random function can also do more things. Inside of these brackets, we can give it some parameters. We can give it, also known as arguments, which can make it behave differently. So if I type in 5 here and 5 here, and we run this now, we see that our circle is moving much faster. Sometimes it's still random. It's picking a random number between 0 and 5. But it's still always going to the right and always going down and never going up or left. That's because it is picking a number between 0 and 5. So what we want to be able to do is be able to assign a negative value. So we type in -5, like this. Now this random function will produce a number between -5 and 5. It's a pretty boring one. Start the next one. Wow. So now it's going all directions. Every time randomly between -5 and 5, both on the X, the horizontal axis, and on the Y, the vertical axis. And what if we wanted the ball to bounce? So rather than going off the screen, it comes back the other way. Well, that's pretty easy to do. We just have to ask a question. We have to ask, if position X is less than 0, which is the left-hand side of the screen, then we want to change the velocity from being a negative number to a positive number. This is how we can do that. If position X is less than 0, then outside of these brackets, we can say what action happens if this is true. If position X is less than 0, it means the velocity X must be a negative number. It must be going left. So we want to make velocity X a positive number. So if velocity X is say -1, we want to change it to 1 so it bounces. How can we do that? Well, there's a trick in maths that if you times something by -1, it flips it. So if something's a negative, it becomes positive, or if it's a positive, it becomes a negative. Velocity X equals velocity X times -1. Oops, I made a mistake. That should be velocity X, not velocity. Hopefully it goes left. Bounce. Oh, that one doesn't bounce. Bounce. Nice. So we currently got it bouncing off the left hand side because we're asking if the position X is less than 0, and if so, flip the velocity. This velocity X equals velocity X times -1 is a bit long. We can shorten it just like we did with the addition. So instead we can say velocity X times equals -1, and it does the same thing. It's just like saying velocity X equals velocity X times -1, and it should still work exactly the same. If this maths doesn't make sense or it sounds scary, don't worry about it. The great thing about coding is you don't really have to understand everything. You just need to know how to look up the answers. And if you've got a reference, you can always go and copy it. And you can always look at your own code to work out how something's done. And eventually you'll remember it and it will make sense. So now we would like it to be able to bounce off the other sides other than just the left-hand side. So if we wanted to be able to bounce off the top side, it's pretty simple. We're just going to copy this line. And instead of if position X, we want to ask if position Y is less than 0. And if it is, we want velocity y to invert the number. So it must be a negative number if position y is less than 0, and therefore we want to make it positive. Should bounce off the top now. Bounce. Oh, it's still going off the bottom though. So how do we deal with that? Let's start with the right hand side. So in this case, we want to ask if position x is greater than the width of the canvas. We can do this by typing greater than 400. Because our canvas is 400 pixels wide, we can ask if position x is greater than 400, then we want to flip the value of velocity x. We don't even need to change this side of the line, because this command here will turn a positive negative and a negative positive, so it will work exactly the same way. I'll put in the vertical line as well. So if position y is greater than 400, then we invert velocity y. Let's try it now. Bounce, 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 bounce. Nice. What if we changed our canvas size? Let's change our canvas size to 500 pixels across and 500 pixels down. Well, now it's bouncing before it gets to the edge of the screen. That's because we're still asking if it's greater than 400 on both the x and greater than 400 on the y. Now we could change this to 500, but there's also a nice trick built into P5JS. There's a variable called width, which is automatically set for us. We're allowed to use it, but it's set for us elsewhere. We can ask if position x is greater than the width, and we can ask if position y is greater than the height. The reason these variables exist is because your canvas might not be a fixed size. You might have a program that works on mobile and desktop, where you've got different resolutions. You might want to be able to change the canvas size whilst the program is running. It's much better to use a variable rather than hard code numbers everywhere. So when we run it now, we see it's gone back to bouncing on all the edges. Mission accomplished. We've completed what we set out to do. We've made a bouncing ball. Pretty simple, eh? The bouncing ball has a property called velocity, and that velocity controls how it moves, how the position changes over time. Okay, we're almost at the end. I just want to show you one more thing. Let's change the colour of the ball. It's been white for long enough. So we can do that by typing the word fill, which is a bit like dipping a paintbrush in paint. Once it's happened, anything you draw afterwards will be that colour. So I'm going to type in magenta. And if we run this now, we've now got a magenta ball instead of a white ball. Ta-da! This concludes episode 1 of my Coding Particles series. I hope you've enjoyed it. Check out episode 2 to learn how to code many particles at once using arrays. In future episodes, we'll learn about adding gravity, how to detect collisions, and how to bounce off other particles when they do collide. Thank you for watching, and happy coding.